Welcome to Mr. Leek's free science tutorials. Now this topic is all about particles. Now the first question that we're going to deal with is describe the particle arrangement and properties of all three states of matter. Okay, so particles first. Particles are kind of the little balls that you see on different diagrams. And the three states of matter, right, what they'll regularly do is talk about the three states of matter. That's your solid, your liquid and your gas. And what a teacher may well do is they may well say to you, what are the three states of matter, right? And quite often people look blank, but you need to remember three states of matter are your solid, your liquid and your gas. Now, we'll come back to that question in a minute. Now, this is then the information. There's your solid, lovely and regular, all the particles all nicely lined up. There's a liquid, lots of particles, but they're all just kind of a little bit higgledy-piggledy. There's a gas, right? And in that gas, what they are is they're just moving around and they're way apart from each other. So, dealing with a solid to start off with. So what a solid is, they are packed in regular structure, strong forces hold in place so cannot move. Right? Now, if you think about, if you had a big tub, right, and in that big tub you threw a load of marbles, right, what those marbles will do is they would pack in a regular structure, and then kind of the gravity holding it all together would then be strong forces hold so they cannot move. And basically those marbles in there wouldn't move. The property of a solid is difficult to change the shape, right? If you've got any sort of property at all, here's a dice, right, there's a solid, right, for me to actually change the shape of that would require a large amount of force, and I would have to overcome the forces that are holding them in place within the substance. A liquid, the particles are close together and the forces keep contact but can kind of move around. If you think about when students are out of lesson time and they're milling around in the playgrounds or on the concrete or wherever it may well be, what they are is they're all kind of moving around randomly, right? But what they are is they're also quite close together. Now with a liquid, they can change shape, but difficult to compress. Right, so if you had a bottle of liquid, not fizzy, right, just a bottle of Ribena or whatever it may be, but you can squish it, right? You can squish it and that'll then change shape. But to actually squish it and make it smaller, to actually compress it, squash it together, is very difficult. Okay, a gas, right? A gas is, if you go back to that playground analogy where you got your concrete out there and there's 5 or 6 year 7s that are just running around all over the place. They are then separated by large distances and very weak forces, right? So they're constantly randomly moving around and they're just moving around all the time. Now they can expand to fill a space and easy to compress, right? If I took a group of 10 year 7s out onto the playground, right, what would happen is they would potentially just sort of disperse, right? And they'd just fill the space, right? But then if I then wanted them back again, I would then say over here, right, they'd all come back and I'm kind of compressing them and they'd all have them into a little area again. Now, back to the question. The question is, describe the particle arrangement and properties of all three states of matter. This is the way that you answer it. The three states of matter are solid, liquid and gas. The particle arrangement in a solid is where they are packed in a regular structure, strong forces hold in place so they cannot move. And a property is the fact that they are difficult to change shape. The particle arrangement in a liquid is where they are all close together and the forces keep in contact but they can move around. A property of liquids is the fact that they can change shape but are very difficult to compress. The particle arrangement in a gas is where they are separated by large distances, weak forces, so are constantly randomly moving. A property of gases is the fact that they can expand to fill a space and they are easy to compress. So back to the question, describe the particle arrangement and properties of all three states of matter. Particle arrangement, three states of matter, properties. Thank you. Welcome back to Mr. Leek's free science tutorials. In this video, what we're going to be doing is we're going to be looking at changes of state. All right, so we've already talked about the states of matter, all right, a solid, your liquids and gas. In this one, we're going to be talking about the states of matter changing between solids, liquids and gases. And the question here is draw a fully labelled change of state triangle. Now, this is basically what you're going to be expected to draw. Now, in an exam, you're probably not going to get to draw that, but if you can then draw this independently all the time, all right, and then there's going to be additional information that then we're going to end up putting on it, right, then you're going to do incredibly well. So, here's the triangle. And basically what happens is a solid can turn into a liquid can turn into a solid, etc., all over the place. These two are the slightly more unusual ones. The best example to always think about is water. Okay, so if we start off with solid water, that's what all the particles look like. Common sense, everybody knows the answer to that one is melt, right? So what happens is the solid melts and it becomes a liquid. And what happens is the particles are then a little bit freer to move. Then what happens is, if you heat it up, the liquid, eventually what it'll do, it'll evaporate. So the liquid evaporates and it becomes a gas. Then the particles are very, very, very well spread out. Going in the opposite direction is, you've got your gas, and then it's condensation. So if you're in your house in a warm house with a cold day outside and you breathe on the window, what happens is, the warm air that's coming out of your mouth condensates onto the cold glass and it turns back into a liquid. You then chuck some water into a cup or a beaker or whatever it is, chuck it in the freezer, it freezes, turns back to a solid. So solid to a liquid, melt. Liquid to a gas, evaporation. Going the other way, gas, condensation, liquid, freezing. Solid, water, is at 0 degrees C, it's basically a solid. Turns to a liquid, 100 degrees C, it evaporates. These two here are then slightly differently, right? What you have is you've got a solid that can sublime or sublimation straight into a gas. And that basically means you could have a solid on the desk, right? And what it would do, it just kind of, no liquid phase, it would just go from solid straight to a gas. That's called sublimation. The opposite way is you could have a gas and that could deposit or deposition straight into a solid. All right, so a gas, deposition, deposit straight into a solid. Now, the question was, draw a fully labelled change of state triangle. So what you need to be able to do is, independently, without your flashcard in front of you, you need to be able to do that. Solid, liquid, gas. Solid to a liquid, melt. Liquid to a solid, freeze. Gas to a liquid, condensation. Liquid to a gas, evaporation. Solid to a gas, sublimation. Gas to a solid, deposition. Thank you. Welcome to Mr. Leek's free science tutorials. Now, the question that we're going to be dealing with in this video is, describe in terms of energy what happens when there is a physical change of state. Right, so obviously to do with energy, physical change of state. So in the previous video, what we did is we went through this, right, which is the changes of state, solid, liquid and gas, and all the different terminology that goes with it. What you need to be able to do now is, rather than just the names, you then need to be able to talk about it from an energy point of view. All right, now, it does kind of make a bit of common sense, really. And what I'll try to do is I'll try to put both the diagrams actually on here. Right, so if we start with freezing. Right, so freezing here, liquid to a solid. Right, these particles are moving a lot. These particles are moving less. So think about the energy, which has got the most energy. They've got the most energy. So they've got more energy, less energy. So liquid turns to a solid, internal energy decreases. Internal energy decreases. Melting. There to there, less energy, less movement, more energy. Solid turns to a liquid, internal energy increases. These particles are moving around more, they've got more energy. Boiling evaporation. Liquid to a gas. Which one's got the most energy this time? The gas, right? Those particles are then moving around a lot more. So liquid turns to a gas, internal energy increases. There's more energy here. Condensation. Gas turns to a liquid, internal energy decreases. More energy, less energy. The particles are moving around. More here, less there. Sublimation. Less energy, more energy. Solid turns directly into a gas, internal energy decreases, or increases, sorry. Deposition, right, even though it's not on this table here, more energy, less energy, so therefore the energy decreases. Two other important key facts to do with this is something called conservation of mass. When a substance changes state, mass is conserved. So if I've got a kilogram of ice and it melts, how much liquid have I got? Water. I've got a kilogram. If I've got a kilogram of liquid, kilogram of water, and it turns into a gas, how much have I got? I've got a kilogram of water gas or water vapour. So that is conservation of mass. Another terminology or another word that could be talked about in your exam or in any test, right, is a physical change. Right, so a physical change is no new substance is made and the process can be reversed. Right, so it's still all water, right, but it's a physical change. So a solid to a liquid is a physical change. Liquid to a gas is a physical change. They're all the same substance, they're just in a different state of matter. Right, describe in terms of energy what happens when there is a physical change of state. What you need to do is you need to describe what is happening on this diagram when there's a physical change of state. So from a solid to a liquid, there is an internal energy increase. From a liquid to a gas, there is an internal energy increase. Going from a gas to a liquid, there was an internal energy decrease. From a liquid to a solid, there is an internal energy decrease again. Solid to gas, sublimation, increase in energy. Gas to a solid, deposition, decrease in energy. That is then the way that you answer that question. Describe, in terms of energy, what happens when there is a physical change of state. Welcome back to Mr. Leek's free science tutorials. Now, this question, right, is one that it's a GCSE question, right, that is quite challenging. And what you do, you need to actually picture in your head exactly what's going on. And what you need to do is you need to really, really think about the reason why this question may be there. It says, explain the limitations to the simple particle model. So the simple particle model is this. Solid, liquid, gas, nice rows, a little bit higgledy-piggledy, gas flying everywhere. All right, that is your solid, your liquids and your gas. The limitations means the problems with, right? How is that simple particle, the model that we talked about there, right, not really correct? Now, solid, liquids and gas. The limitations of the simple model, the one that we talked about here, your solid, your liquids and your gas, all right, with all the little particles and stuff like that, right, is what you should actually have on there is you should have forces. All right, now on these, right, there are no force diagrams, no force arrows, because what's actually happening is between all the particles there are forces happening. That is one of the limitations. All particles are shown as spheres. They're not spheres, right? In later when we talk about the actual particles themselves, they're made of protons, neutrons and electrons, right? And right smack bang in the middle in the nucleus, what you've got is you've got protons and neutrons, tiny little area in the middle, and the electrons are then flying around the outside. So they're not a sphere, right? And they're definitely not a solid sphere. So they're then the limitations of what this actually is. Common question. Explain the limitations to the simple particle model. Now, to answer this question, what you need to do is you need to firstly explain what the simple particle model is. So the simple particle model is where you have solid, liquid and gas, and they are shown as individual particles. Solids, nicely arranged in straight lines. Liquids, moving around a little bit, but still with forces between them. Gas, very, very small forces between them, right, and moving around rapidly. That's then your simple particle model. the next part of it then is explain the limitations. And what you would do is write down the limitations to the simple particle model are: there are no forces in the model, no arrows, all particles are shown as spheres, and the spheres are solid. So what you've got is, you've got your explanation of a simple particle model, which could be worth 3 marks in a 6-mark question, and then you explain the limitations, and the limitations are then those 3 things here. Okay, thank you very much.